Now you notice that at the moment I'm just thinking about what happens to 1. So this thing on the screen, I'm just thinking about what happens to 1. But if you look at the bigger picture, if you look at the entire complex plane, you notice that the entire complex plane gets rotated and also gets stretched. Yeah, so it's not just 1 that gets stretched and rotated, it's the entire complex plane. Which means that I should be able to multiply by any complex number I like. Okay, so for example, I'm going to stick with multiplying by 1 plus I, but I'm going to think about a different number multiplied by 1 plus I. So let's choose, for example, let's try 1 minus I. So let's think about what 1 minus I times by 1 plus I would be. So where would 1 minus I be on the screen? You can just kind of...
In the second region?
Fourth, yeah. Yeah, fourth region, so yeah, it goes round, right? So 1, 2, 3, and then the fourth one, perfect. And you're happy it's just 1 across and 1 down, right? So keep your eyes fixed on that position. Let's see where it ends up at. Okay, so if we just watch that position, we do our rotation. Still got it? Yep. And then we do our stretch. So where does 1 minus I end up with when we multiply by 1 plus I? Not quite. Look carefully. Do you want me to do it again?
We are multiplying with this number with 1 minus I.
Yeah, exactly. All I want you to do is keep your eyes fixed on that 1 minus I. So if you like, just draw a point, if you know, in your brain. So let me do it again.
Okay.
Draw a point, okay?
Yeah.
Where he's got 1 minus I, literally just draw a point and then keep that point in your mind and see where that point ends up at, okay? So let's do our rotation first. Still got it? Yep. And let's do our stretch. Now having a look, because I've overlaid the previous axis on top of it, where does it end up?
Ends up at 2, 0.
Perfect. Absolutely right, yeah? It ends up where 2 used to be. Does that make sense?
Yeah, we were pointing at young one.
Yeah.
Yeah? So if you look underneath, you've kind of got that axis, right?
Yeah,
and it literally ends up at 2, and there's 2 there.
Yeah.
Does that make sense, Chun?
Yeah.
Yeah? So in other words, what I can say, just thinking about what we've learned here, you know, rotation and stretching, if I take 1 minus I, and if I multiply it by 1 plus I, so this is the action, okay? This is the action, I'm multiplying by 1 plus I. I'm multiplying by its modulus, sorry, I'm stretching by its modulus, and I'm rotating by its argument. I'm proposing this should be equal to 2. Because just thinking about the visualization of it, right? If I take this number and multiply with the 1 plus I, so I stretch it by the modulus of that number and rotate it by the argument of that number, I end up where 2 used to be, okay? And of course, you can verify this yourself. So this is just a binomial, you can expand it out. So 1 times 1 is 1, negative I times 1 is negative I, 1 times I is positive I, and negative I times positive I is negative I squared. Tidy this thing up. Negative I plus I, cancel. I squared? It's negative 1, good. So if I do a negative of negative 1, you get 1 plus 1, which is 2 as well. Yeah? So yeah, it kind of consistent, it makes sense. So are there any questions about this?
No.
Good, fantastic.